Lesson: Understanding Algorithmic Transparency and Fairness. Algorithmic transparency and fairness are crucial components of the digital age, particularly as artificial intelligence, big data, and the Internet of Things become increasingly integrated into various sectors. These concepts are paramount in maintaining ethical standards and trust in automated systems. Algorithmic transparency refers to the extent to which stakeholders can understand and trace the decision-making processes of algorithms. Fairness in algorithms ensures that these systems do not perpetuate biases or discriminate against any group. Addressing these issues is vital for information privacy professionals, especially those pursuing certification as a certified information privacy professional. The primary challenge in achieving algorithmic transparency lies in the complexity and proprietary nature of many AI systems. A practical tool to address this is the use of explainable AI frameworks. XAI focuses on creating AI systems whose decisions can be easily interpreted by humans. One effective application of XAI is in the healthcare industry, where clear understanding of AI-driven diagnostic tools is essential. For instance, researchers have developed models that highlight which features of a patient's data led to a particular diagnosis, providing transparency and allowing healthcare providers to trust and verify AI recommendations. Moreover, algorithmic fairness can be operationalized through various fairness-aware machine learning frameworks. These frameworks include pre-processing, in-processing, and post-processing techniques to mitigate bias. Pre-processing involves altering the input data to remove bias before it is fed into the algorithm. For example, techniques such as reweighting or resampling the data can ensure a more balanced representation of different groups. In-processing techniques modify the algorithm's learning process to avoid bias during training. Post-processing involves adjusting the algorithm's outputs to ensure fairness. Each of these techniques can be implemented depending on the specific context and data availability. A practical example of addressing algorithmic fairness is evident in the hiring process. Many companies use AI-driven tools to screen resumes, which can inadvertently perpetuate biases present in historical hiring data. By applying fairness-aware frameworks, companies can adjust their algorithms to evaluate candidates based on merit rather than biased historical patterns. This was demonstrated when a major tech firm revised its recruitment AI tool after discovering it was biased against female applicants. By altering the algorithm to disregard terms that were historically skewed towards male candidates, they achieved a more equitable hiring process. A significant step towards ensuring algorithmic transparency and fairness involves the use of accountability frameworks. These frameworks mandate regular audits of AI systems to detect and correct biases. For example, the Algorithmic Accountability Act proposed in the U.S. requires companies to evaluate their AI systems for discriminatory impacts and to rectify any identified issues. Such legislative measures compel organizations to prioritize fairness and transparency in their AI systems. In addition to legislative frameworks, ethical guidelines and industry standards play a critical role in promoting algorithmic transparency and fairness. The IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems, for example, provides comprehensive guidelines to help industries develop transparent and fair AI systems. These guidelines emphasize the need for stakeholder engagement, ensuring diverse perspectives are considered in AI development. By adhering to these ethical standards, organizations can create AI systems that are not only transparent and fair, but also aligned with societal values. Furthermore, real-world applications of algorithmic transparency and fairness are evident in the financial sector. AI systems are used extensively for credit scoring, which directly impacts consumers' financial opportunities. A lack of transparency and fairness in these systems can lead to discriminatory practices. To address this, financial institutions are increasingly adopting transparent models that allow consumers to understand the factors influencing their credit scores. Additionally, regulatory bodies require these institutions to regularly assess their algorithms for bias, ensuring fair treatment of all applicants. This proactive approach not only enhances consumer trust, but also aligns with regulatory compliance. Professionals in the field can also leverage practical tools such as fairness dashboards, which provide visual insights into how algorithms perform across different demographic groups. These dashboards highlight disparities and assist in tweaking algorithms to enhance fairness. For instance, a fairness dashboard can reveal if an algorithm disproportionately favors one group over another, prompting necessary adjustments. This tool empowers organizations to continuously monitor and refine their AI systems, ensuring sustained transparency and fairness. In conclusion, understanding algorithmic transparency and fairness is essential for information privacy professionals navigating the challenges of AI, big data, and IoT. By employing frameworks like explainable AI, fairness-aware machine learning, and accountability measures, professionals can ensure that AI systems are transparent, fair, and ethical. These strategies, coupled with adherence to ethical guidelines and industry standards, provide a robust foundation for developing and implementing AI systems that gain public trust. As AI continues to permeate various sectors, maintaining transparency and fairness will be pivotal in upholding the principles of privacy and equality. Through actionable insights and practical tools, professionals can address real-world challenges, enhancing their proficiency and contributing to a more equitable digital landscape. SME.